So, a couple things before we get going. So that second exam went pretty well. I think the lockdown browser might have had a small impact on scores, but the average is right around where I'd like to see it. So, if you look at mean versus median, we don't talk too much about that in this class, but I think the median across the two sections was like right at an 80, and the mean was a little bit lower, like a 76. So, I mean, some people didn't do as well, but on average, kind of right there at that B minus is where the kind of average score was. So, excuse me. As we're thinking about kind of wrapping, we're 2/3 of the way through this course now. We've got 2 more weeks. So this week we'll do module 10, module 11. So that module 10 reading I kind of mentioned last week was due before we started today. Module 11 reading, we'll start monopolies on Wednesday. So that's due before we meet in class on Wednesday. And then module 12 will start Friday, kind of finish on next Monday. Then module 13, Tuesday, Wednesday, review Thursday, and then our final exam that following Friday. So, we're kind of, going to go move quick kind of towards the end of this class. I'll have things set up like I did the first 2 weeks. So this week, I'll have a module 10 quiz. It'll pop up tomorrow. That'll be due by the end of the day Sunday. Same kind of idea with module 11's quiz. Once we're done covering that material, it'll pop up on Canvas. It'll be due at the end of the day Sunday, as well as the participation quizzes with module 10 and 11. And then everything from module 12 and 13 will be due at the end of the day next Thursday, that night before we have the final exam on next Friday. Okay. Other than that, I think that should kind of cover everything. Before we jump into material, any questions for me before we get started here? Okay. So we'll start with module 10. And we're going to be talking about, for the rest of the semester, types of markets, right? So the main type of market we're going to have as kind of our baseline comparison is a perfectly competitive market. So what are some of the characteristics? We've kind of always been using these markets when we're talking about firms in the previous modules. But we're thinking about markets where there's no barriers to entry, so firms can enter and exit. And we'll talk, I think, more about this tomorrow. We're going to have many buyers, many sellers. So we've used this a little bit in the past where nobody has any influence over the price. So once we talk about monopolies, that's going to look a little bit different. But for now, we're assuming you can always find someone else to buy this product from. You can always find someone else to sell it to. And so nobody has any influence over the price. Okay? We're also going to assume, starting out, that we have a homogeneous product. So this is like everyone is selling the exact same thing. Once we get to module 13, monopolist competition, we'll talk about what if the products are slightly different. Right. But for now, we're assuming everyone's selling the exact same product. So, everyone's selling 87 on unleaded gasoline, or everyone's selling, the exact same kind of bottle of water. We'll talk about what happens if that isn't the case, but we got to walk before we can run. We need our baseline comparison, which is this perfectly competitive market where goods are perfect substitutes. Okay. And this fact that we have many buyers and sellers leads to everyone's a price taker. Nobody kind of has any influence over the price. Okay. So what's not going to be true about these markets? This is going to look more like monopolies and other things we talk about. There's no barriers to entry. There's no legal restrictions about being able to sell products in this market. Nobody has control over a scarce resource, so that, let's say everybody, there was one company and they owned all of the, had all the gold reserves in the United States. Well, no one else can make anything out of gold unless they are purchasing some of that scarce resource. So we kind of are assuming in these perfectly competitive markets, everyone has kind of access to the resources required to build this good or produce this good. And then we're not going to have any geographical barriers. We'll talk about natural monopolies in module 11, but that there's, you can easily kind of transport this good to and from different locations, and so that nobody is going to be like the only seller in one specific region. So, this is just kind of setting us up. So we're thinking about these markets. No one has influence over the price. No one has control over, being the only person you can buy from. So in perfect competition, we'll talk about kind of how firms are going to behave. So we talked a lot in module 9 about implicit, explicit costs, and that firms are going to maximize profits. And to be a little more specific here, we said they're going to maximize economic profits. So we're going to choose a production level, right, based off of what the current demand for this product is, or what the demand curve looks like, that's going to maximize our economic profits. Okay? So once firms choose this quantity, then there will be some overall quantity in the market, And because they have no control, there's many buyers, many sellers. What'll end up being true is at every single price, that is what I have to sell the good for. That is the firm's marginal revenue. Right? Whatever the equilibrium price of that good, settles on, that's going to be the marginal revenue each firm can produce, or sorry, each firm can earn selling this good. Okay, so we can kind of think about if we had like the market for gasoline, market supply and market demand. Here, our equilibrium price would be about $3. So there will be some overall quantity, equilibrium quantity in the market. We're not going to be concerned with that right this second. But whatever that price is, when we start to think about the firm's decision, well, we could look at different quantities. We talked a lot about the firm's average total cost curves, their marginal cost curves. But what is the firm's marginal revenue curve? Well, if they have no influence over the price, whatever that price is, if I try to charge anything higher than $3, how much do I sell? Nothing, right? So our firm's demand will be this horizontal kind of curve, I guess, horizontal line at whatever the current equilibrium price is. Okay. Just to kind of give a little bit of an idea, really what's going on, and I won't usually draw it like this, but starting out to kind of think about it, I said that their demand curve, the firm's demand curve. So usually I'll kind of write like market demand as a capital D. So we're thinking about kind of that as market demand. Here we're thinking about like each firm's demand curve. Well, the reason why the firms don't have this downward sloping demand curve is because if they charge a price that's, let's say, anything above that current equilibrium, how much are they going to sell? Zero. So really, the firm's demand curve like runs along this y-axis, and then once it hits that equilibrium price, in our example that was 3, well, now I can sell as many units as I want at that price, because that's what the price everyone else is selling it for. So I know I am be able to find buyers who are willing to pay that price. Now, why would I, if prices ever went lower? Well, I mean, there I'm just sacrificing not making as much money. If everybody else is charging 3, everyone's going to kind of lower the price. We'll talk a little bit more about what that would look like. But for now, any price above the equilibrium, the firm would sell 0. So they're going to charge that equilibrium price. That's their demand curve. Okay. Let me see here what I have. I think I might jump the gun a little bit. Well, yeah, I'll hold off on this. We'll go back to the slides here. So we'll come back to this. This is mine. Well, I'm going back and forth. We'll have it in the slides, but I can show it to you here as well. So I think it'll make more sense. So let's say I've got some price and quantity, and here I've got market supply, and here I've got my market demand. Okay. Here I'm thinking about, this is the quantity each firm is producing, not the total quantity in the market. So here we're just thinking about, what does the firm's decision look like? Well, we just said whatever that equilibrium price is, so I'll call this first equilibrium price. That would be the firm's, kind of lowercase d here, demand curve. Okay. Now let's say we had something that shifted either supply or demand. Okay. So I think, I did a demand change in the slide. So we'll do a supply change here. So let's just say, let's assume that we have, I don't know, some new cost-cutting technique. Remember, supply represents our marginal costs. So let's say there's something that decreases, or that market supply, so it decreases our marginal costs or increases the market supply curve. Right? So if we have something that changes the changes the overall market supply curve, that could be something that was changing the individual firm supply curve. But what's that going to do? We talked about this. It's going to lower that equilibrium price. Okay. So the firm's demand curve would now be whatever this lower equilibrium price is. Okay. So the firm's demand curve comes directly from the market, and any shifts that we would see in the supply curve would cause that firm's demand curve to shift as well. Similarly, if we had things that shifted the demand curve, so here I start out, let's say I've got market supply and market demand. Let's say I have something that not increases supply, but it increases demand for the product. Well, now intuitively, right, we said, okay, people want to buy this more. What's going to happen to the equilibrium price? Well, when we draw in that demand increase, our new equilibrium price is a little bit higher. So now the firm, instead of charging $3, can charge that equilibrium price of $4. That would increase the firm's demand curve. So we can see things that shift supply or demand in the market, and then that's going to shift the individual firms' demand curve. And I think about here, I've got marginal revenue on this y-axis. Really, this is just representing kind of dollars. For us right now, the demand curve of the firm is also their marginal revenue, right? Because when I sell a product, what's the additional revenue I'm earning? Whatever I'm selling it, whatever price I'm selling it for, right? So the individual firm's demand curve can also be thought of as the firm's marginal revenue curve, okay? Any questions on that idea? We'll kind of throw in costs here in a second. So when we think about what the firm is trying to do, when are they going to make a profit? Okay. Well, if we go back, what are profits? It's simply going to be, or sorry, if we go back, when we introduce this idea of economic profits, it's simply going to be the total revenue earned by the firm compared to the total costs, right? So economic profits are the total revenue minus the total cost. So anytime total revenue is above total cost, we're earning a positive profit, right? If they're the exact same, we would say the firm is earning zero profits or they're breaking even. And then anytime our total revenue is below our total cost, we said that the firm is going to be having negative profits or we're going to be incurring a loss. Okay. So these are our three kind of possible outcomes for the firm: positive profits, negative profits, or zero. Okay. And we'll talk about how we can compute the exact value of profits, but for now, we're just going to be thinking about those ranges. So I just kind of have a simple little table here where I've got gasoline, and I have, if the firm is producing this many units, right, what is the total revenue that they're earning? So looking at this, what would my marginal revenue be for each quantity? Well, just like marginal cost was the change in total cost divided by a change in quantity. Here I've got change in quantity of 1, so that makes it a little bit easier. How much is my total revenue going up by? Each time I'm selling one more unit, looks like I'm making $4 additional. So it must be that the equilibrium price is $4, right? So anytime I'm thinking about the firm's marginal revenue or these perfectly competitive markets, that change in total revenue over the change in quantity should always just be the equilibrium price of that good. Okay, so for now, I was coming up with these costs here. We said that we know the marginal costs are increasing. That's what we learned in Module 9. So I had here, just to kind of review, if the firm produces nothing, what must we be in, short or the long run? Well, if I still have total costs, I know that I'm in the short run, right? I must have some fixed costs, because if I'm producing nothing and I still have costs, they must be fixed. So I've got some fixed costs. This firm's in the short run. And then as they produce more, well, initially it goes up by what? 3.8, and then it only goes up by 3.2. So maybe my marginal costs are going down initially, but eventually they'll start increasing, right? So if I get down to here, now I'm seeing like jumps of 8, 9. My marginal costs are increasing. So there's going to be a point where when I'm selling the first unit, the additional revenue I'm earning might be greater than the additional costs, right? So I'm selling this unit for $4. How much was it costing me? Well, it looks like 3.8. Okay, well, I made 20 cents on selling that first unit. So I've lowered my profits. Shouldn't say lowered. I've increased my profits, right? Because before they were -6, now I'm making 0.2. So now they're only -5.8. Now they're still negative, but a smaller negative value is better for a firm, right? I'm actually maximizing my profits because going from -6 to -5.8, my profits are going up. They're increasing. So we notice that as the firm starts to produce more and more, they're selling more units. Their total revenue is going up. Now their total costs are going up as well, but the difference in between that total revenue and the total cost, notice at these low quantities, it was negative. At this quantity of 5, it now becomes positive. Okay. Now, if they continue to sell more and more goods or produce more and sell more goods in this market for $4, eventually they get to this quantity of 10 where they're earning what? The difference between total revenue and total cost is 9.5 here. So that's the highest profits that they can earn. If they try to sell the 11th unit, well, there, the total revenue minus the total cost is only 8.1. I'd actually be worse off if I produced and sold that 11th unit, right? So we're going to talk about why. There's going to be something about the relationship of marginal revenue to marginal cost. But for now, if I was given just the total revenue and total costs, I'm just looking for the quantity where the difference between those two, or my profits, difference between total revenue and total cost, is maximized. Okay. So what's going to end up being true, right, is if I'm thinking about, right, I've got quantity that I'm selling. What did I have in here? Yeah. Oh, I want to be able to see this. There we go. So if I thought about what is my total revenue? Well, for every unit I was selling, it was making $4. So I get to kind of think about, I actually had a well, nope. I'm getting ahead of myself. Let's do this. If I sell nothing, my total revenue is nothing, right? So I've got a total revenue curve that looks something like this. And the slope, or my marginal revenue, is simply going to be whatever that equilibrium price is. Every unit, additional unit I sell, I'm earning whatever that price I can sell it for is. Now, what we're also going to see is if I have my total cost curve in here, right? So initially, I've got, however I would, if I wanted to graph kind of what my total costs were, we said even when I'm producing nothing, if I have some fixed cost, it might start at a positive amount, right? My total cost is going to be something, right? Now, those total costs might be increasing, right? Now, eventually, I'll get to this point, and I might think, okay, well, this is where my total revenue is equal to my total cost. So what should be true here? Profit should be 0, right? But this total cost curve won't be straight. Why? Because we talked about in Module 9, what's happening to marginal costs, right? We said the slope of this total cost curve, it's not always going to be the same. Marginal cost is the slope. So we said marginal cost, maybe initially it's going down, but then we said eventually marginal costs start to increase. So what's probably a more accurate representation of the total revenues and total costs of a firm would be something like this. So our marginal revenue is still going to be the same for every unit. So our total revenue curve, the slope is always the same. But for our total costs, maybe initially it has a very flat slope, but eventually those increasing marginal costs start to take over and my total costs go up by quite a bit. So what we're really looking for is, okay, this point and this point, my total revenues are equal to my total costs, right? So I theoretically would have like two quantities, right, where profits are equal to 0. However, the firm is trying to maximize profits. They don't just want 0 profits, they want the largest positive value. Well, what is that represented by? Well, notice here, the difference between total revenue and total cost, that gap would represent my profits. So here profits are positive, but that gap keeps getting larger and larger. Now it's kind of hard without actual values here, but it looks like somewhere around this quantity, that gap in between total revenue and total cost is at its greatest. And then if I keep producing here, my additional revenue stays the same, but my additional cost, that slope of the total cost curve, starts to go up. So my profits, the difference between total revenue and total cost, keep going down. Now they're 0 again. What's happening in this range? So at these quantities, this would actually be profits that are negative. Same kind of idea over here. My total costs are above my total revenues. So there my quantity would be negative. Okay. Anything in this blue range, there we were having quantities where profits are positive. There's only going to be one point where they're maximized or at their largest, but this is going to be how we could kind of depict that. Now, when we start to talk about firm decision making, we usually won't look at this graph because ultimately what this graph is telling us is the quantity where profits are maximized is the point where the additional revenues are the exact same as kind of our additional costs. So it's something about the slopes, right? But just to kind of give a foreshadowing, this is what we're trying to find, where the gap in between our total revenue and total costs is maximized. Okay? So instead of doing that, we know that individuals and firms make decisions on the margin. So marginal revenue, I kind of already alluded to this, that slope of our total revenue curve, which is a change in total revenue coming from a change in quantity. Same kind of way we calculated marginal cost, just looking at revenues. Okay? So we've got marginal cost and marginal revenue. Excuse me. Our optimal production rule, and I'll give a little bit of insight into this, is going to be the quantity that maximizes profits will actually be the quantity where marginal cost is equal to marginal revenue. Okay? So we can kind of think about why. If profits are the difference between total revenue and total costs, what is my marginal profit? So if I'm thinking about when my increase by one more unit, well, there's going to be, this is a little bit like, I don't know, a little more mathy. I'm not sure everyone's math background, but if we take a derivative of something and, we're subtracting, we can take a derivative of this minus whatever the derivative of this is. So a derivative is really what we're looking for when we're looking at the margin or the change. So the change in profit from selling one more unit will be the change in the total revenue from selling one more unit minus the change in the additional costs, right? That difference will be how much I'm adding to profits, okay? So as long as my marginal revenue is greater than my marginal cost, I'm going to be having a positive value here. I'm adding to my profits. As soon as my marginal revenue becomes less than my marginal cost, well, now I'm adding a negative value to my profits. So what's happening? My profits will be going down. And then the point where they're maximized, or the last unit where kind of I've got profits as high as possible, is going to be where marginal revenue is equal to marginal costs. Okay. So we'll look at this in table form, and I'll try to kind of give some formula and a graph that kind of helps support this. But you can kind of think about, if I'm maximizing profits, I want this change in my profits to be positive. If this is the change in my profits, it's only positive when marginal revenue is above marginal costs. Okay? So we'll go back to our example. We've got an equilibrium price of $4. I've got my total costs here. As I'm selling more units, my marginal revenue is the same. Now, this was the idea that we have kind of this linear marginal revenue curve. My marginal costs, initially they're going down. So what must I have going on for these quantities? We said gains from specialization. Now, once we get to that 6th unit, looks like past that point, my marginal costs start to increase. So there we must have diminishing returns taking over. So if I'm looking at, I could use my total revenue and my total cost to calculate the profits. It's the same thing we had in the earlier slide. Notice that when profits are going up, right? So even though these are negative, they're smaller negative values. What's the difference between my marginal revenue and marginal cost? It's always positive. My marginal revenues are above my marginal costs. As long as that's true, my profits are increasing. So for this 10th unit, my marginal revenue is still just above my marginal cost. So my profits are still going up, not by much, but by a little bit. So you can kind of think about that difference between marginal revenue and marginal cost is how much producing and selling that unit is going to add to my profits. So notice here, if I produce the 6th, that difference between the additional revenue and the additional cost, I sold it for $4, it cost me $1.50. I made $3.50. So my profits went up by $3.50. Now, any quantity past 10, what starts to be true? All right. My marginal revenue is now below my marginal cost. So now that difference is negative. If I produce past 10, I'm just decreasing my profits there. Okay. So total revenue, right? the point where total revenue, actually here, I copy and pasted this and forgot to change it. It's not total revenue greater than, sorry. It's total revenue minus total cost, or where my profits are maximized, will be the last quantity where the marginal revenue is greater than marginal cost. Or if we have a more continuous table, it would be the point, where marginal revenue is equal to. That would be the last quantity that we would see the firm produce. If they were equal, what would we say the firm is? Well, if marginal revenue is equal to marginal cost, what's the change in profit? 0. So we would say firms are indifferent, right? Where they could produce up to that point, they'd be just as well off if they produced at that quantity or the quantity right before. Okay. So what does this look like in the graph? Well, we've got our increasing marginal cost. We said some quantities will have gains from specialization, then diminishing returns take over. So this difference between marginal revenue and marginal cost is how much is being added to profits, or the change in profits from selling each additional unit. As long as that's positive, we want to produce those units. Up to the point where they're equal, we said they'd be indifferent. Any quantity past that, well, now if my marginal costs are greater than my marginal revenue, I'm just adding a negative change in profits, or I'm decreasing my profits there. Okay. So, here, what do I have here? We won't do a demand shift yet. I want to do a little bit more here before we keep moving. So, I kind of think about, got my quantity, dollars here. I've got, here's that total revenue curve. Here was like my total cost curve. So if I'm trying to kind of map this out for us, I want to try to get this all in the same, yeah, there we go. So, well, I'm not sure if you can see that. So I'm just writing total cost so we can make sure we know that's the total cost curve. We said that marginal revenue, or the change in my total revenue, will always be the same. So what was that looking like? Well, remember, whatever that equilibrium price is, we said that's the firm's demand curve, or that's the firm's marginal revenue curve. Whatever that equilibrium price is, we're going to have this constant marginal revenue. Now, our marginal cost, notice, initially it's pretty flat. And then that slope, maybe we said initially we've got kind of this decrease in our slope. We said before, we know that profits are maximized at that quantity where the gap in between my total revenue and total cost is at its largest. What'll end up being true is that gap is at its largest when the difference between my marginal revenue and marginal cost is exactly equal to 0. They're the exact same thing, right? So this quantity that maximizes profits for the firm, right? Instead of looking at total revenue and total cost, we can also use the marginal revenue and the marginal costs, okay? And kind of just to point something out, you can kind of see this is kind of tricky, I guess, but like, notice here, remember, these are like the slopes of my total revenue and total cost curve. So notice here, when the slope is flatter, my total cost curve is flatter. That means the marginal costs are lower than the marginal revenue. Now, as soon as, if I had like a line of tangency drawn, so at this point, the slope of my total cost curve, or the marginal cost, it's the exact same. It's parallel to my total revenue, or my total revenue curve. The change in my total revenue is marginal revenue. Past that point, my marginal cost now become, my total cost curve becomes steeper, which means my marginal costs are higher. Putting them above that marginal revenue, there we know we were earning negative profits, or kind of, I shouldn't say earning negative. We would be adding negative amounts to our profit past this quantity, because the additional costs of these units are greater than the additional revenues. So you can kind of think about any quantity in this range, my marginal profits would be negative, and then any quantity in this range, my marginal profits will be positive. We like positive marginal profits because that means we're adding to profits, okay? So it's a slightly different way of kind of thinking about it there, okay? All right. So we know that this quantity where marginal revenue is equal to marginal cost will be that point where profits are maximized. Okay. What that also means is we want to produce up to the point where the marginal cost, well, what is the marginal revenue of the firm? We said that is the equilibrium price. So I typically write E's. You'll see like in different resources or books, sometimes instead of an E, you'll use like a star. So I sometimes will use that to kind of represent the equilibrium, just because you might see that if you're looking up outside sources. But really, we're looking for where does that price of the good equal the firm's marginal cost? That's where profits are maximized. Okay. So we already kind of discussed, though, that yes, we can identify that quantity, but what happens if something changes in the market? So initially, if I had this good and equilibrium price starts out at 3, the optimal quantity for the firm, or the quantity that maximizes their profits, might be right here. If I have a demand increase, well, what's that going to do to my equilibrium price? It's going to push my equilibrium price up, right? The new firm's demand curve will be higher because the firm's demand is simply that equilibrium price representing the marginal revenue earned on each unit. Well, intuitively, compared to the old point, if the marginal revenue is now higher at every unit, should I be choosing to produce more or less than I was before? More, right? And so what we see is the new optimal quantity that maximizes profits. If I see a demand increase that pushes that equilibrium price up, the optimal quantity for the firm will also be higher. Okay. Any questions over that before we keep moving here? Okay. I might be going a little bit slow here. Yeah, 45 minutes. I'll do another one just to kind of give you another example. I think it's worth our time. So let's instead assume that I had something like this. So I've got my quantity in the market. Here I'm thinking about quantity that the firm is choosing. And usually I'll write kind of the quantity of the firm as a lowercase q. So we had initially, here was our supply curve. Here is our market demand curve. Here is our equilibrium price, right? So that's going to be the firm's initial demand curve. They've got some increasing marginal costs. So kind of the optimal quantity for the firm there. So usually when we're thinking about optimal, that's where I'll kind of use those stars as opposed to just the equilibrium of a market. What happens instead if there's something in this market, and let's say it increases supply? So maybe the firms can lower their costs. Maybe more firms enter this market, which drives that equilibrium price. So here's our new equilibrium price. Probably should have put a 1 here. Okay. Well, that doesn't change the costs of the firm, but it does change how much they can sell the product for. So the firm's demand curve, we would say, decreases, right? Intuitively, if the price of the product goes down, am I going to want to produce more or less than I was before? Well, if the price is my marginal revenue, right, then the point where marginal revenue hits marginal costs, I know is going to be at a lower quantity. So anything that pushes that equilibrium price down will cause each firm to produce less than they were before. Okay. This isn't like a perfect way to think about it, but using my number of firms example, if more firms join the market, there's like the same, maybe people want to buy about the same amount. The influence that's really going to have is that now like we're splitting the same demand, but each firm's getting a smaller amount. That's not completely quite accurate the way I just described it, but that might be a helpful way to think about it, right? Anything that increases supply, right, means that each firm, even though we see that the quantity in the market goes up, each firm is actually producing a lower amount. So it's kind of counterintuitive that when I have these supply increases, you could actually see the equilibrium quantity in the market go up. So this is the idea: if there's more firms that join this market, you see the quantity go up in the market. However, each firm is producing a lower amount, right? How can that happen? Well, if I have 2 firms producing 100, that's 200. If I have 3 firms producing 75, well, that's 225. So the market quantity could go up even though each firm is producing less. Okay. All right, so we can have supply and demand shifts that influence that price and then kind of shift our firm demand curve and change their optimal quantity or the quantity where they would maximize profits. Okay. So what's another way of calculating profits? I'm going to kind of break this down in an equation that'll be helpful for us when we're thinking about other types of decisions that firms run into. So the first thing I'm going to do here, just a little bit of rewriting. What is total revenue? Well, in our perfectly competitive markets, I sell every unit for the same exact price. That's my additional revenue earned. So price times quantity would be total revenue. Now my total cost, I'm going to do a tricky thing here where I simply multiply it by 1. So I haven't changed anything when I multiply it by quantity over quantity. However, if I rearrange this a little bit, what is total cost over quantity? That would be my average total costs, right? Well, if I'm multiplying both of these by the quantity, I could rearrange this so that profits are simply the quantity I'm selling times the difference between my price and my average total cost. Okay. So this only works when we have kind of this constant marginal revenue or these perfectly competitive markets where each firm is selling the good at whatever that equilibrium price is. Okay. So we started out with this very simple profit equation, total revenue minus total cost. We'll see how this formula, I just rearranged some things, why this form of our profit equation can be also helpful. Take the quantity, multiply that by the difference between price and average total. Okay. So I'm going back to that same example. And what I'll see is even if I don't have the total revenue and total costs, and when we're looking at these firms, a lot of them, we don't know, they don't necessarily put their costs out there or exactly. But we always can figure out probably what their marginal revenue is, right? Simply by, that's going to be whatever the equivalent price of the good is. Now, let's say I had their average total costs, right? I could look at, well, first of all, where's the optimal quantity? It's going to be where marginal revenue is equal to marginal cost. So it should be, we said, right at that 10th unit. If I wanted to calculate average total cost, right? Let's say I had those values over here. I could also calculate my profits, not as total revenue minus total cost, but the quantity I'm selling times the difference between price and my average total cost. So if I do that here, I have what? 5.8, negative 5.8 times 1, negative 4.8, or sorry, no, 2.4 times negative 2.4 times 2, so on and so forth, right? So I can kind of use that equation where I'm taking the quantity, multiplying it by the difference between price and average total cost. Now, what do I notice? When are profits positive? Well, with my total revenue and total cost, it was when total revenue was above. But I also know that, whenever that price is above average total cost, profits should be positive times a positive. So notice here, whenever that price is below the average total cost, so for these quantities, the price was below average total cost. What was true about my profits? They're actually negative. As soon as my price is above the average total cost, well, now my profits start to become positive times a positive, so positive. And then eventually, we know the average total cost curve has this kind of U shape to it. So initially, my average total costs are going down. But remember, eventually, they'll start increasing again. So notice as soon as those average total costs are above my price again, what should be true about my profits? Now they're negative again. And where's the point where they're maximized? We kind of already identified that. That's where that price is equal to the marginal cost. So we can calculate profits using that relationship between price and average total cost, but choosing that optimal quantity will still be based off of where the marginal revenue is greater than or equal to the last point where it's greater than or equal to the marginal cost. Okay. Any questions there before we keep moving? Okay. So just to kind of give a visual of this, and I kind of referenced this already, but what did we use, or what did we talk about in Module 9 that we can use? Well, we know the average total cost will kind of have this U shape to it. We said the marginal cost intersects the average total cost at its minimum point. Okay. So what's the optimal quantity? Well, it's going to be where that marginal revenue or the equilibrium price is equal to the marginal cost. It looks like it's at a quantity of 11 in this graph. That price is above average total, so this should be, profits should be positive. In fact, if we've done this correctly, that should be the point where profits are also maximized. But how could I use this graph to calculate what the value of those maximized profits are? Well, I would go over here. It's not as easy. I don't have a continuous grid line here. But if I could come up with this, I don't know, 3.3, or, if I was able to identify from the grid lines, I would have the average total cost at the optimal quantity of 11 is about, I think I have some value, 3.05. What is the price? Well, that's the marginal revenue of $4. Take the difference in between those two, multiply it by that quantity of 11, and I'd end up with positive economic profits of 10.45 here. Okay. So from a graph, I can also identify where is the optimal quantity, where marginal cost is equal to marginal revenue, and then at that quantity, what's the difference between that price or marginal revenue and average total cost? Multiply that by whatever that optimal quantity is. Okay. So anytime my optimal quantity or where marginal revenue is equal to marginal cost is at a point where the price is above average total cost, I'll have positive profits. What happens if instead I had an example like this? So let's say, I don't know, some of the costs change. It looks a little bit different. Where is my profit maximizing point now? It looks like it's at a quantity of, well, where does marginal revenue equal marginal cost? 8. So for every unit here, the additional revenue is greater than the additional costs. So the firm keeps producing. Once we get to that quantity of 8, that's where profits should be maximized. So we can actually have examples where when the firm is maximizing profits, remember, maximize just means getting them as high as possible. It could still be that profits are negative. So in this example, right, if I look at my price relative to the average total cost, the average total cost is, oh, I don't want that there. Go away. There we go. The average total cost is actually a little bit, right, higher than my price. In fact, I could play around with these different values. I guess it doesn't quite match out here, but the relationship should stay the same, right? The average total cost is above my price. Multiply that by the quantity I'm selling, and I see, oh, okay, my profits are negative there. However, it must be the smallest negative value. If I produce past that point, marginal revenue is below marginal cost, it must be that I would just be decreasing my profits. So profits can still be negative at the profit maximizing point. That's going to present us with some additional issues that firms have to think about. But simply identifying where the profit maximizing quantity is, we can have negative or positive profits. And that's all about the relationship of the price to the average total cost. Okay. I think I've got an example here. Yeah, the break-even price, or where would profits be equal to 0? Well, if I had, and actually, I should have just drawn the line in here, but I can draw this on out for us. So let's say I had, here I'm thinking about the quantity of the firm, so they're making this decision. So I've got my average total costs. I've got my marginal cost, which intersect them at their minimum point. If I had an equilibrium price, which is the firm's marginal revenue, if that was equal to marginal cost, that should be our profit maximizing quantity. But notice, if it happens to be that that price is equal to marginal cost at the minimum point of our average total cost curve, what would profits be? Well, if profits are the quantity I'm selling times the difference between price and average total cost, what's the difference between price and average total cost here? 0. So anything times 0, this would be our point where profits are 0, or our break-even price. Right? Any kind of price above that, right? What do we say is going to happen? As soon as my price goes up here, that's my new marginal revenue. Before I do this, first of all, sorry, I'm getting ahead of myself. Are there any questions on this before I keep moving? Because I'm going to add some colors and things to this graph that complicate it a little bit. Okay. So anytime I see something that increases this equilibrium price, what has to be true about my new profit maximizing quantity? Well, my new marginal revenue would have to be hitting my marginal cost somewhere in this range, right? So some quantity over here, what's going to be true? Marginal revenue hits marginal costs at a point that's what? Above the average total, right? So any price above the minimum, so if I had a price that was above that minimum point of my average total cost curve, my marginal cost will hit that marginal revenue at a point where price is going to be right above the average total cost, right? So even if it was up here, right, now my price is still above average total. So if I have a price, an equilibrium price in the market above that minimum point, that was our break-even price, right, or our break-even quantity where profits were zero. As soon as the price goes above that, I know price will be above average total cost. If my price is greater than average total cost, this will be positive. Quantities are positive in this range. So there I would have positive profits. Okay. If I ever see the price fall below that break-even price, right, or that minimum point of the average total cost, what's true now? Well, now I'm going to hit my marginal revenue is going to hit marginal cost at a quantity in this range. For every quantity in this range, what's true about my marginal revenue relative to my average total costs? Well, now this new equilibrium price is below, sorry, anytime that equilibrium price was below the minimum average total cost, well, now my price will be below the average total cost curve, right, at the profit maximizing quantity, which must mean that my profits are prices below average total cost. Now my profits are going to be negative. Okay. So anytime, if we can identify that the minimum point of our average total cost curve, that's the price in the market that would give firms zero profits. If the price ever goes higher than that, we know the firm will be earning positive economic profits. If the price, for whatever reason, we have supply or demand shifts, is below that minimum point of the average total cost, now we know we're going to end up in a scenario where the optimal quantity is actually earning negative profits. Okay. All right. So where are we at in time? Okay, we're good. So I added a little bit more to that graph that I think hopefully will be helpful. You can kind of see any price above that break-even price, positive profits, any price below negative. And that's kind of intuitive, right? If the price is higher, past the point where profits are zero, I can earn more profit, right? Higher positive profits. If the price is ever below that point where I'm earning zero profits, I'm not making as much, my profits will now be negative. Okay? So the fact that we could see the equilibrium price result in negative profits, we know the firm is then going to have a second decision. So we can identify what quantity would maximize profits, but even though that point maximizes profits, should I stay open? Because if those profits are negative, if I had no fixed costs, we'll use that simple example. If I had no fixed costs, what are the profits if I shut down? Well, I'm not earning any revenue, but I didn't have anything that I was like locked into paying. And so if I produce nothing, if I have no fixed costs, my variable cost would be zero. So my profits are zero, right? So if I do nothing, it could be that maybe I'd be better off shutting down. Now, in the short run, it's not quite that easy because we do have some fixed costs, right? So here we can kind of think about, I'm really wanting to compare, are the losses from staying open greater than or less than the losses of shutting down? Now, if I have fixed costs, my losses essentially, I don't have any revenues, my losses or my profits would simply be negative, whatever my fixed costs are, right? So we'll run through some, numerical examples here, but you can kind of think about firms make these decisions. It might seem like, well, why are we worrying about this? Like if the firm leaves, they leave, what's the decision? Well, firms can choose to shut down in the short run, right? Or in different seasons. So like ski resorts have done the cost benefit analysis, compared their marginal revenues to cost. In the summer, it doesn't make sense for them to stay open, so they shut down. Right? Restaurants in some resort towns, maybe they don't completely shut down, but they limit their hours, right? There's places around Bloomington that definitely change their hours when students, during the spring, fall semester compared to the summer, right? Really, like a lot of examples we see of this where like they're not just completely shutting down, but they might shut down for periods of the year. Probably things that are kind of related to like seasonal issues, right? So what is the shutdown rule that these firms are going to make, right? Well, we said before our profit equation, we had quantity times the difference between price and average total cost. So if price is below average total cost, we said profits are negative. So should we stay open? So we'll rearrange the equation to end up at a rule, the shutdown rule, that hopefully as we kind of rearrange this, it'll make a little more sense. So here is our profit equation before. It was the quantity we're selling times the difference between price and average total cost, right? How much money I'm making on average per unit minus how much money I'm spending to make on average each unit times the number of units I'm selling. That's really what that profit equation is saying, okay? So I'm going to break down average total cost into its two components. We said average total cost will be the same as average variable plus average fixed. So instead of subtracting average total, I'm just going to subtract average variable and subtract average fixed. Haven't changed anything. Okay. I'm then going to rearrange this a little bit, right? So I'm going to take quantity times price, quantity minus my average variable cost, and then I'm going to have minus my fixed costs here. Because if I multiply quantity by my average fixed cost, what does that give me? Just my fixed costs. So from this equation, hopefully I can kind of see, okay, if I shut down, what are my profits? Well, if I shut down, the quantity is 0, so my profits would simply be negative fixed costs, right? If I stay open, right, and the price is below average variable, well, what would this second part of my equation be? Another negative value. So all I would be doing is going from having negative fixed cost if I shut down to even larger negative profits if I stay open if price is below average variable costs. Now, if price is above average variable costs, well, there, if my fixed costs were negative, I shut down, that would be my profit. But as long as price is above average variable, I'd be adding a positive amount. So even though my profits might still be negative, if price was below average total cost, as long as my price is above average variable costs, then by staying open, I'm actually minimizing my losses, which is another way of saying I'm maximizing my profits. Okay. So I've got a visual here, but I'll kind of give you some numbers. Maybe that'll, so let's say, I don't know. So I've got my profit equation. We said we can now think about it as price minus average variable cost minus my fixed costs, right? So, kind of think about, let's say I had price was equal to 20, average variable costs are equal to 30, and my fixed costs are, I don't know, 100, right? So in this scenario, right, price is what? Below average variable costs, okay? So if I shut down, what would my profits be? Well, simply negative fixed costs, right? 0 times anything is 0, and then just my fixed costs. Let's say, just to make it easy, we're doing a quantity of 10 here. If price is below average variable cost here, if I continue to stay open, what would this firm's profits be? Well, I would have negative 100 as my fixed cost, but now at the optimal quantity of 10, if the price is below average variable cost, well, what would that difference be? Negative 10 times 10. So I would have negative 100 minus, another 100. So I'd actually be losing $200. So in this scenario, price was below average variable cost. So what should I have done? Not stayed open. My profits were actually higher or a smaller negative value if I shut down. Okay. Well, now let's think about, okay, let's say that price went up to, I don't know, let's make this in the easy. Let's do just barely above average variable cost. Let's do 31. Okay. So if this firm looks at this, well, price is above average variable cost now. So if I shut down, my profits are still just negative fixed costs. But now at this higher price, if I stay open, what are my profits? Well, 31 minus 30 would be 1 times 10. So I would have 10 minus 100, or if I stay open in this scenario, my losses are a little bit smaller, right? So as soon as that price gets above my average variable cost, it actually makes more sense for me to stay open. I can minimize my losses or maximize my profits by staying open. For any price that's below my average variable cost, I'm a little worse off if I stay open compared to shut down. Any questions on this idea? I'll kind of give you a different way of visualizing this now. Okay. All right. So, if I'm thinking about what this is going to look like, we now not just have our average total cost curve. We said if the price was ever $3, where it hit the minimum point of our average total cost, any price above that, we said profits were going to be positive, and any price below that, profits are going to be negative. Well, that's still going to be true. So this shaded green area, if I drew the firm's marginal revenue or their demand curve, any price in the market, equilibrium price above 3, that's going to hit my marginal cost at a point where the price will be above average total. I'll have positive profits. So in the short run, if we saw the price go below that minimum point, we said profits would be negative. But there's going to be 2 ranges in that negative profit area. The first is going to be if I see a price that's anywhere above the average variable cost, but below my average total. Well, it's below average total, so I know my profits will be negative. But if it's above average variable, remember we said if price is above average variable, I'm adding some positive value to profits here. That would make profits not, a little bit higher than if I simply shut down. So any price in between the minimum point of our average total and average variable cost, we're going to have negative profits, but the firm should choose to stay open. Now, if the price ever falls below that minimum point of the average variable cost, well, now when we look at that profit equation, we would just be adding another negative value to our negative fixed cost or making profits even larger of a negative value. So what should we do? Well, then we shouldn't stay open. We should just shut down and pay those fixed costs. Okay. So these are our kind of 3 different ranges. Okay? Price above average total cost, positive profits. At the optimal profit maximizing quantity, price below average total, the minimum point of our average total, but above the minimum point of our average variable. Well, there the optimal quantity would result in negative profits, but they'd be profits that are closer to 0 than if we just shut down. And then any price below the minimum point of the average variable cost, that's where if we stay open, our profits will be a larger negative value than if we simply just shut down. All right. Any questions on that? What do I have here? We'll do that next class. So I just kind of have a short summary of those 3 ranges here. All right. So let me think about what I want. I think we got that participation quiz I want to work through, but I'm trying to think if there's anything else I want to say here. I think I will, but only if we have enough time. So we got 15 minutes, so we should have time. There is one more thing I want to do, but I don't think it's needed for this quiz. So let's take a look at, let me make sure I hit publish as I was getting into this. Should be under that module 10 heading now. Okay, yeah, I published it. All right, so. So look at this first one. And I've got the points set up so even if you get this wrong, you're getting the 2 base points for this quiz. So you don't lose half for getting it wrong. So let's say I was looking at this graph and I want to know what's the break-even quantity and price. Well, I don't have these curves labeled, but I know what they are. And this is where this class isn't cumulative in terms of the final exam asking you questions from say module 8 and 9, but we're using what we talked about in previous modules and just building upon it. So what do we know has to be true? Our marginal cost hits our average total and our average variable at their minimum point. So this blue curve should represent our marginal costs. Which of these curves is our average total cost? Well, the black and the green curve, average total and average variable. Average total is average variable plus average fixed, so it has to be higher. So this black curve is our average total cost. This green curve, which is lower, is our average variable cost. And then the curve that hits them both their minimum point, that must be our marginal cost. So we're looking for that break-even price and quantity. It's going to be where profits are equal to 0. So that's going to be at that lowest minimum point of the average total cost curve. So here, if the price was what? 425, it would be my marginal revenue, right? That equilibrium price is the marginal revenue. It hits marginal cost at a quantity of 350, and it's exactly equal to my average total cost, so profits would be equal to 0. So 350 was that quantity, and 425 should be that break-even price. Okay. Any questions? Actually, we can do a preview so we don't see the answers ahead of time, but make it a little bit more, I think, useful. All right. So we said what? 350 and 425 was that break-even point where profits become positive. Okay. If instead I had a marginal revenue of $125, well, first of all, if it's a marginal revenue of 125, we said with a perfectly competitive market, the marginal revenue is the equilibrium price. It must be that equilibrium price is $125. What should the firm produce if that's the case? Well, if I look here, where does that price of 125, so it's going to be here, go over. Now, this is where it usually won't give you something like this on like the exam or a quiz. I was just kind of building these quickly. If you have sometimes these prices and it hits the marginal cost on the gains from specialization point, when we're finding the optimal quantity, as long as we know we still have gains from specialization, we wouldn't stop at that quantity. So it looks like at 125, it's going to hit marginal cost down here. However, right, we know that the company, as long as they still have gains from specialization, they're going to continue to produce. They know that then eventually those marginal costs will be below that marginal revenue of 125. Now they continue to keep going until the marginal revenue hits their marginal cost on the diminishing returns portion. That's at a quantity of what? 225, right? So you might be like, okay, the quantity is 225. However, so, maybe I put in 225 here. That would be wrong. Why? Because at that quantity of 225, the point where profits are maximized, if I stay open, so that marginal revenue being equal to marginal cost, that is where profits will be maximized if you stay open. Now, if I then have the decision, okay, if I stay open or shut down, where would I be better off? Well, here we'll be at a price that's below my average variable cost. So we said anytime price is below average variable, when we rewrote that profit equation, we would see, oh yeah, I'm just adding a negative value to whatever my fixed costs are. I might as well just shut down. Adding 0 to my negative fixed cost would be better than adding a negative value to negative fixed cost. So when my price is at the optimal quantity of 225 is below average variable cost, I actually should be producing nothing. Right? Okay. Now, what if I've got a price of 350? Well, that price of 350, first of all, what's the minimum point of my average total cost where marginal cost hits it? It's at 425. So the price is below that. I know that I'm going to be earning negative profits. But exactly what value would that profits be? Well, at 350, that marginal revenue hits marginal costs at a quantity of 325. Okay. So 325 is going to be my quantity. Okay. Now, if I look down here, I already forgot. Oh, there we go. So 350, I'm looking at a quantity of 325. So there my price is above average variable costs, right? So I know that my profits, I should stay open. However, that price is below average total, so I know they're going to be negative, right? So if I'm looking at that quantity, it looks like my average total costs, and these graphics are probably a little bit off. So I mean, what, 325, I'm looking for the difference between price of 350, average total cost of like 425. So let me see what I have this set, just so I don't have to, well, I can pull up Excel here. I didn't mean to exit out of that, sorry. What do I have in Excel? Yeah, as I say, let me just get this opened. Do a new sheet. So I have what? 350. No, I already forgot what the values were. what did we say this was? So we had at price of 350, quantity was 325. So 325 times the difference between 425. 325 times the difference between 425 and 350. Did I do this correct? So 24. Why is this a little bit off? Oh, because it's slightly above 425. So I probably was like, no, because I was doing these with numbers and then I changed it to a visual. So just to make sure everyone gets this one correct, right? It's you can't quite identify. So I'm guessing I did like what? Oops. No, probably 4. No, I don't know what value I did there. Probably split the difference. I'll go in and just give everyone credit for this one. But basically, the reason why this is a little bit inaccurate is because if I had a graph like this, it's slightly above 425. So it may not be clear what the actual value is. Maybe it's, 430, maybe it's 435. But the actual process you would use is you would simply take that difference between whatever that average total cost is at that optimal quantity of 325, right? And take the difference between 350 and whatever that average total cost. So that's what I was doing here. I was taking that quantity of 325, and then it would be multiplied by the difference between whatever that price was. And, if we had more fine grid lines, whatever this exact kind of value would be. Okay. I'll go in though after the fact. If you're watching this, you should be able to get this correct. But I'll kind of give everybody credit for this one so we kind of talk through it. Now, in future questions, be careful though. So even though I can compute that value, I was kind of being irresponsible when I was doing it this way because why? What is the actual equation? It should not be my average total minus my price. It should actually be the price minus my average total. So the profit should actually be negative there. Okay. So that's why I should have kind of this negative value. Okay. We could even back engineer. What must I have been using here? What, like 433? No, 432. Nope. 431. That is what I used. Yep. So that's kind of, playing around, or no. Is that right? Nope. Well, I don't know what I was doing, but that would be kind of what you're using there, right? You're just plugging it in. Once you can find those values, it's either this equation, but we had the average total cost, so we actually could use simply this equation. Okay. All right. And we'll revisit this next class. We'll kind of start picking up on this shutdown rule example, because I also want to go through kind of some long-term stuff. We have a few more minutes. There is one more thing I wanted to touch on, which is, let's say I didn't give you, let's see if I have one up here. We can actually use the quiz. So let's say I didn't give you what my fixed costs are. So let's say we had one like 2, and we know we should shut down. Okay. So I know I should shut down, but I wasn't told what fixed costs are. So what would my profits be for this firm in question 2 if they chose to produce nothing? So what's one way I can find my fixed costs, right? Well, my average fixed costs would simply be the difference between my average total and my average fixed. So I can look at any quantity. So I think this one looks like this will be a good quantity to choose. At that quantity of 350, what's my average variable costs? 200. And what are my average total costs? 425. So at that quantity of 350, so our average total cost was, I already forgot, it was 425. And my average variable costs were, what did we say? 200. Okay. So if I shut down, right, what should my profits be? Right. So we had this price. It was something like, I don't know, 150, way below our average variable cost. So we know we should shut down. So how could I find my profits? Because I know if I shut down, my profits are just negative whatever my fixed costs are. So again, I can do a little bit of, multiply this by 1, quantity over quantity. Well, I could rewrite this as, which is negative average fixed cost times quantity. How can I find my average fixed costs? Well, that's just the difference between my average total and my average variable. So at that quantity of 350, my average total cost was 425. My average variable cost was 200, right? So there, negative 225 times 350, whatever that works out to be, that should be the value of my profits if I shut down. So how did I find that? Well, I know that my profit should simply be negative fixed costs. Wasn't told those, but if I know my average total and average variable, I can find out that my average fixed costs was just the difference between those two, so 225. And then I know that I was looking at how did I find those averages is at a quantity of 350. And you could really do that at any of these and find the same value. So let's see another one where they kind of hit two lines. So like right here, I could do 425 and the average variable is 250 and the average total looks like it's 450. So I could use that point as well to kind of calculate the average fixed and then multiply that by that higher quantity 425 to find what my fixed costs are. We'll work through some more examples. I think we'll have quite a bit of time actually tomorrow at the end of class, and we'll work through maybe some of the practice problems where I'm just giving you numerical values. I'm probably a lot more likely to do that in a question like this as opposed to give you these grid lines because as you can kind of see, it's hard to get them, exactly to kind of hit at a point where you're not kind of guess, oh, I'm in between these two, what's the exact value. So we'll run through some numerical examples tomorrow as well. And then, we really don't have a ton here. We've got a couple like firm entry and firm exit. So I'll probably go through a lot of examples tomorrow and work through some of those practice problems that you should be able to find under that module 10 heading. So we've got practice problems, the answer key, and then their solutions. So I'll work through some of those tomorrow as well because I know that we'll have ample time to cover the material. Okay. So any questions on that before I end the recording here? Okay.